In today's demanding global economy, productivity is essential. This usually refers to facility uptime, product quality, and competitive production costs. The largest obstacle that manufacturers encounter to achieving this goal is power quality-related problems, such as outages, harmonics, and surges. But the most common and costly problem is voltage sags. Omniverter has a solution for your facility. Although voltage sags can be caused by many events, such as animals touching two voltage lines, starting large loads, or a fault on the line, the most common is weather-related. Storms normally bring high winds, rain, and lightning, which can cause problems for clean sinusoidal voltage distribution. Although the utility companies try to keep tree limbs away from the power lines, it is not possible to prevent these events from happening. As the limb touches the power line, the voltage at this point will drop to zero. Due to voltage contribution from parallel lines and some loads, the voltage appears at the facility as a sag. If the voltage event is longer than a few cycles, fuse or breaker operation would clear the fault and return the system to normal. Depending on the depth and duration of the voltage sag, sensitive electrical or electronic loads may be affected. Costly downtime, material scrap, production equipment damage, and product quality issues can be the result of sag events. The Omniverter Active Voltage Conditioner, or AVC, was developed specifically to reduce or eliminate the costly effects of voltage sag events on sensitive electrical systems. The AVC is an active voltage conditioner that constantly monitors the line and load voltages. A closed loop forward sensing design is used to accurately detect voltage sags on the line. Energy is drawn from the line and fed to the rectifier, which then feeds the inverter section. The controller calculates the required voltage vectors needed to restore the voltage to the sinusoidal magnitude and phase angle required. The appropriate compensating voltage is then injected through the series-connected transformer. The entire sequence of events are sub-cycle, less than 4 milliseconds. Since there is no energy storage device within the AVC, it can continually provide sag protection as well as voltage regulation, which is more common today due to utility deregulation issues. Since an electrical distribution system is extensive and complex, it is susceptible to voltage sags at any point and at any time. Protection for your electrical system from costly sag events is a sound and practical investment.